With you today, we have four great speakers. We got Patrick Allen of Dairy Farmers of America. We got Kai Kruning from BASF, Pete Barry from Sani-Matic, and Ton Anslinger from Chevron. They'll be speaking in that order after I start off with an introductory presentation. With them, we're very fortunate enough to also have five great panelists. We got Wes Sylvester from Cisco Systems, and Andreas Henneke from Pepperl+Fuchs, John Vincente from Stratus Technologies, Travis Cox from Inductive Automation, and Eric Rasmussen from Rockwell Automation. So without further ado, I'm going to kick off with the presentations, and then the presentations are naturally going to follow one another. And then when we're done with that, we'll have a live Q&A session. And I know from as you've been attending multiple ARC sessions thus far, if you have any live questions you'd like to ask, hit the Q&A button on the bottom of your screen, and we'll get to them the best we can. And if we don't get to your question today, we'll certainly submit it to the person that the question is targeted to try to get your response sometime after the forum. So with that, why don't we kick off my introductory presentation, please.
Hello, everyone. This is Craig Resnick from the ARC Advisory Group. Today, I'd like to talk about IIoT convergence, which we certainly consider to be one of the foundations for digital transformation. And, some of the things we want to cover a little bit today is what drives IIoT convergence. I mean, what's the cause and why it's been such a hot topic over the last several years. And actually what makes it the foundation for digital transformation, because you really can't have digital transformation if you really have not begun the IIoT convergence process. We can talk a little bit about some of the shifting market demands caused by what we consider to be the new normal. A lot of the new normal was driven as a result of the pandemic, and that certainly caused a great number of changes the way people are operating. And we're going to also talk a little bit about how IIoT convergence is evolving, and some of that evolution is as a result of the pandemic. We're also going to see where today, especially, the needs of IT and OT are a lot more common than you think. I think at one time people thought of them as things where they had completely different objectives and expectations of outcomes. But I think you're going to see that there's a lot more in common with IT and OT convergence today than there has been in the past. And ultimately, it has to be the benefit of everybody in the manufacturing and processing community, because otherwise there's no really need to go through this whole IIoT convergence process, and then we'll wrap things up a bit. So again, something we've been hearing a lot about for the last several years, the whole IIoT convergence phenomenon. And one of the things that there used to be when this process was beginning, the IT side would sometimes look at OT and say, wow, your people are using a lot of products and a lot of technology that are pretty old and really don't keep up with all the latest trends in technology, especially in areas such as, let's say, cybersecurity. And then, of course, on the OT side, the challenge becomes you don't understand real time. You don't realize the fact that this is something that has to be in real time, and that it's something that you just can't decide to stop a process or run a report. Operations typically have to be running and available 24/7, because the worst problem you can ever have in OT is downtime. So that's an area, those are two areas where each group had to kind of get to understand each other's pain, shall we say. But again, you don't have a foundation in digital transformation if you're not beginning this whole IIoT convergence process. And digital transformation has been one of the great accelerators of IIoT convergence. It takes this tighter integration, because there's no way that you can get the data that you need today, run the appropriate analytics software, use that data to operate your business, send that data, whether it be edge-mounted devices or data that would be up and sent to the cloud. You can't do that today without certainly the combination of both IT and OT. And it's something that in many factories, it's really part of the IT-OT convergence is part of the digital transformation journey. At no point can you really progress with that journey if you have not really begun the process itself. So digital transformation is obviously one of the factors that drives this to happen, But at the same time, you really can't go through the digital transformation process if you're not beginning the ITOT convergence as it takes. Now, let's talk a little bit about the pandemic and the new normal. And what it's really come up with is companies at one time, especially in the digital transformation journey, were always just looking for the metrics. What is the ROI? Why I can't really go through the digital transformation process unless you can show me I can measure what's that return on investment. But now all of a sudden, as a result of the pandemic, you started to have the variable, which we call operational resilience and business resilience. But it's like, now, is my business set up that I can take a disaster, whether it be a pandemic issue, whether it be a climate change issue, whether it be a geopolitical issue? Because what's happening is that now you have to make sure that your company can continue to operate. Can you maintain the real-time visibility of your supply chain? And can you react quickly to market shifting? Can you react quickly to the fact that the people who are running your plant may now be having to work remotely? And they need that real-time visibility and control so they can actually make do the right monitoring and make the right decisions, even if they're not physically within the plant. So what this has done is it's really broken down a lot of these boundaries. And I can say one thing with this new normal is it's probably accelerated the digital transformation process much faster than if the pandemic had not happened. It's a shame we had to have a pandemic to accelerate it like this, but it certainly has moved things along out of necessity. But again, that necessity is to build the operational resilience to run these factories and plants today. But again, without the ITOT convergence, you're not going to be able to have this kind of flexibility and agility that you need to, for example, have that real-time visibility on your supply chain and the ability to make quick decisions and the ability to operate your plant from any location. And this has really created a lot of new methodologies for this new normal. And but it's also, how do we protect the personnel? How do we install the right cybersecurity protection to make sure that if we are operating the plant from a remote location, that we've taken the necessary precautions and we have the appropriate, firewall technology. But the thing is that you really can't do that if you don't have your ITOT convergence story moving forward. So again, do you want to operate remotely? You want to be able to achieve that faster business value? You have to be able to make sure that, again, that no situation of not having access to the plant or not being able to get your workforce into the plant is not going to be paralyzing for you. And if your supply chain is cut off from one area, they're able to quickly reestablish a supply chain from another region or another geography or another supplier. So it's going to change the way that people work and the way that organizations are designed and the way that workflow is processed, the way that teams now connect to each other. And it's really going to provide a higher level of visibility and transparency throughout the organization, because that's what it's take to properly operate in this new normal. So in some respects, it's a shame that it took a horrific disaster like a pandemic, but it has really accelerated a lot of these things that may have been 3 to 5 years from actually occurring. So we're all familiar with the old traditional IT and OT groups, where the OT side of the people that are running the operations and the process of the plant, and the IT portion of the people that are doing the, that are responsible for a lot of the programming, cybersecurity, dealing with cloud technology, virtualization, analytics, for example. But what we found is that we're now needing to put these groups together. And what's happening is we're starting to lose that space between the groups. So it's almost becoming one single group. So the companies that are the most furthest along with IT-OT convergence, actually, we have a new term at ARC called IT-OT fusion. And that's how we see it all evolving. Because again, if we look at the needs of IT and OT from the past, and then as we have seen them come together, where issues like cybersecurity and standards and the issue of no downtime and being able to have pure measurements for ROI and ROA to help justify projects, and certainly the incorporation over the last few years of industrial Internet of Things. And we've seen this begin to come together, but now, Again, we're seeing this all become fused together. So eventually these groups are just going to become one. And as the needs become the same, the drivers become the same, now you truly have what we call at ARC as ITOT fusion. And think of some of the benefits that you get as a result of having this right now, as far as minimizing process variability and minimizing process upsets, using less energy, increasing the quality of your product and having fewer product reruns and less waste, maintaining the health of your assets better, which is certainly going to help to eliminate or minimize any unscheduled downtime, and pull the workforce in and give them greater engagement, and be able to predict a problem of a potential failure before it actually happens. So you can take the predictive and prescriptive actions as you would certainly by able to deploy the analytics software. And the whole issue of cognitive learning, because as now you have the ability to take for artificial intelligence and machine learning, but also from the human side to be able to leverage technologies like augmented reality and virtual reality to give you a better perspective as to what's going on in the plant, and also be able to provide training as well, certainly on the virtual reality side. So if in summary, we see ITOT confusion, and as that's evolving as part of the digital transformation process, it's really going to be able to help companies get the most out of their workforce, to really streamline work processes and better adapt to this new normal. May get the kind of insights it needs to run the business more efficiently and from any location, because you have that operational resilience built into your business. You're now not going to longer be paralyzed by issues of your supply chain. If there's an issue with one supplier, the ability to make quick decisions, or if there's a quick change in the marketplace in product and consumer demand, to make those fast decisions in real time, almost bringing real time to making supply chain decisions. So it really takes advantage of the best of both worlds, best of the IT world, best of the OT world, and fusing it all together, all accelerated by the new normal. So with that, I want to thank you very much. And we got some great speakers in this session that'll talk about their ITOT stories as well. Thank you very much and have a great day.
Hi, my name is Patrick Allen. I'm the Director of Network Services for Dairy Farmers of America, and I wanted to talk to you about our journey from COVID to Convergence. First of all, we want to cover a little bit about who Dairy Farmers of America is for any of you who are not aware, go over some of the challenges that COVID presented to us, and then some of our non-traditional convergence and lessons learned, and then lastly, what's next. I look forward to spending a few minutes with you guys today talking about the journey we've been on since the beginning of COVID, but really it's been a much longer journey that was compressed thanks to COVID, as I'm sure many of us have had that issue. Dairy Farmers of America, DFA is the largest supplier of raw milk in the world. We're headquartered here in Kansas City, Kansas, and we're a global dairy cooperative owned by dairy farmers, which is really exciting to be a member, an employee of this company. A little bit more about DFA. We have a very diversified product portfolio, from fluid milk to ice cream to powdered to supply chain. We have 87 manufacturing facilities around the continental United States, 20.1 billion in US sales, and we are the third largest global dairy company. So for challenges. In March of last year, as everybody in the world, became aware that COVID was not going to be something that just went away. As a critical supply chain company, supplying milk to schools, milk products to various parts of the world, we had some really distinct challenges. We had to protect our plants, we had to protect our employees, and we had to be able to deliver our product around the world. So some of the three major things that we looked at was we wanted to make sure that we were increasing worker safety and productivity by enabling social distancing measures. This is not one of those jobs where you can do remote. When you're on the plant floor operating machines, when you're having a shift changeover, when you're having lunch, right? All these things are things that cannot be done from home. It'd be awesome if it could, but that's not a path that we're at yet. So we had to keep our employees in the plants. Additionally, we wanted to maintain overall workforce continuity by reducing exposure to COVID-19. While we may be having to be in our manufacturing facilities, manufacturing our product, we want to make sure we're doing it safe, effectively, and ensuring that we're not transmitting COVID or any other sickness or disease following our USDA guidelines. And lastly, maximizing equipment uptime with subject matter expert support. When something breaks, how do we fix it without flying somebody in? Because now there's some new challenges that are presented. So typical IT convergence talks about unified networks, data analytics, big data, cybersecurity, high availability, edge computing, and a few other ones that I'm sure you'll hear from others today. However, our convergence, and specifically what we were asked to address, wasn't what we typically cover when we talk about IT-OT convergence, and that's collaboration. How do we ensure our frontline worker and our knowledge workers are able to interact safely, effectively, but remotely? How do we ensure that our vendors who support our large manufacturing facilities are able to support and do maintenance and not planned maintenance, unplanned maintenance, outage work? How do we do that without presenting a risk of bringing COVID-19 into our plants? While DFA as a whole, we've got a lot of things that we're doing on the traditional IT-OT convergence side, I want to talk to you guys today about the collaboration side. So using OT collaboration. So how do we leverage remote experts when travel is restricted? At the beginning of COVID, before we found a solution, when we needed somebody to fly into a plant because something was broke or we had an outage where we had to do maintenance, we would have to fly in our employees, corporate engineering teams, our vendors. We'd fly them in 2 weeks in advance for them to sit in a hotel and work from a hotel remotely, but they could not enter a plant until that 2-week quarantine had taken place. And while they were doing other work, that's a massive cost for the hotel rooms and et cetera, but also it takes time. If we have a major outage, we have to wait 2 weeks before we can bring somebody in, which means we could have a downtime of up to 2 weeks, which is unacceptable. And then along with that, how do we keep the plant running in the event of an unplanned maintenance or outage? And the way we're going to do that is by connecting our remote experts to our frontline workers. So how did we do that? We partnered with Cisco, and we brought to them, these are the issues that we're having. These are the challenges. We got to run 24/7, 365. Almost all of our plants run 24/7. Travel for key personnel was restricted, and for those that were able to travel, again, hit that 2-week quarantine. And our usual efforts to prevent outages and maintain uptime is limited, right? We have less experienced personnel at certain facilities, and so we'd have centralized engineering experts who would travel to these other facilities to help support them when they would only have a plant technician versus a plant engineer. And how are we going to be able to continue to support these our other manufacturing operations who don't have engineering expertise in-house? So working with Cisco, we brought in the RealWear HMT1 headset. It's a partner solution with Cisco. We use Cisco Wireless throughout our entire facilities. And through WebEx Expert on Demand, we were able to enable our frontline workers to reach out and ask for help or schedule a time to meet with vendors or subject matter experts to be able to work through an issue, even bringing up new equipment, doing periodic maintenance, asking a question. All of those things that we would previously require an on-site trip now would all require is a video call. These headsets have been had varying levels of success, which we'll talk about later. But our plant operations personnel were working together for continuous operations during times of crisis. And again, travel was a big deal. We traveled a lot before. And the results of this is very surprising, to me at least, was we maximized our uptime. We limited truck rolls, air travel, regional and national sites. Our production supply was maintained throughout all of COVID, and even still. And then we're continuing to leverage social distancing techniques. And one of the additional things that we did working with Cisco was Traditionally, when you talk about video conferencing, you're talking about, okay, I'm going to talk from here to there. I'm going to talk from facility A to facility B. Well, we actually leveraged it in a little bit more of a unique way where we'd say at our facility here, we have 5 conference rooms and we can only fit 2 to 3 people per conference room. And we need to do a production supervisor shift change so we can talk through the different things that happen during that shift. Where before we'd all get into a room and chat and walk through it. Now we had the ability to get on a video call and have 2 people in each conference room, be able to still have that face-to-face interaction, be able to have the communication, be able to have the turnover between shifts so we can have seamless operations and talk about issues, talk about, whatever's going on, but within the same facility, which traditionally you wouldn't do. But we're trying to think outside the box and find new opportunities for us to leverage the technologies that are available to us while also keeping social distance. So, we're keeping that for contact tracing, even that the 2 shifts would not be in the same room, that we'd have 2 people from one shift in one conference room, 2 people from another, right, and keep it divided like that. And it was actually extremely helpful to help protect our workers. So the case study, right, I talked about, we have to run 365 days a year, 24/7. We can't travel, or when we do travel, we have 2 weeks of downtime. So we wanted to provide real-time, anytime visibility. We have multiple. I'll give you an example. One of our engineering supervisor at our facility in Portales, New Mexico, has several instances where he's gotten called at 2 or 3 in the morning from a frontline worker who had an issue. A Torx drive or a PLC or an HMI was down. Plant was a machine was down. And normally he would have to wake up, get dressed, and go into the plant and troubleshoot the issue. But through the solution, the smart headset, the HMT headset, we were able to, or he was able to go in, log onto his computer in his pajamas, walk through the issue with the frontline worker. And this is right middle of the night. Most of our key knowledge workers not in the office. And was able to work and troubleshoot a problem to eliminate downtime to get the plant back up and running without ever having to leave his house. And it's not something he's had to do once. It's just something he's there, that is becoming normal operations. When there is an issue, they're able to work through it remotely, and which is very exciting. And it increased employee productivity and visibility, right? Being able to go home, and that was a big thing. Is we were having times where workers would have to stay at the office for extended periods of time. And now we don't have to do that. And if we have somebody working in Kansas City, they're able to engage and access the facilities around the country. And through our subject matter experts being, dispersed around the country, it's been a huge benefit. Additionally, bringing in our subject matter expert vendors and being able to ask them questions as well, and getting them onboarded and trained on our solution has been really helpful. So we're going to move on and talk a little bit more about OT collaboration. Like I said, we're using Cisco WebEx, a RealWear HMT1, and the video conferencing hardware. Our new hardware, right, again, limited in-person meetings, and we're leveraging this at multiple facilities now and continuing to grow the adoption of this mentality, not just the social distancing, but being able to have shift change meetings between multiple conference rooms in a single facility. Our engineering teams leverage this were leveraged remotely, as I discussed, and plant maintenance at multiple facilities with zero travel. The interesting piece, is the not exponential growth, but increased demand and desire to have this capability for other departments that aren't necessarily related to OT, but are part of our governance, compliance, research and development. Even IT wants a piece of this. When something breaks, we've been trying to leverage this to walk through and figure out what the problem is remotely. Our QA teams being able to, again, travel's still not something that we're doing. So being able to get back to a semblance of a new normal, I know everybody's heard that a bunch and it's exhausting to hear, but defining how we can continue to do our jobs and not have to wait until this passes, but understanding that it may not for a while longer, and being able to walk through and work through each piece of the business, and being able to take OT innovation and spread it back across to the other departments has been really exciting. Here's a view of the headsets. Remote engineer can talk and annotate, is able to take a picture and say, hey, touch this, and click in. Actionable insight, and being able to just walk through any frontline worker, even an unknowledgeable office worker, can be walked through how to fix something. So here's some benefits and concerns. Real-time remote expert guidance, reduced travel expenses, COVID-19 requirements, spacing, third-party support. One big piece is we want to develop internal knowledge instead of always going to vendors, but continue to increase the ability to fix problems internally. And as we walk through frontline workers on an issue, the next time, the goal is, and the hope is, that now that they've done this one time remotely themselves, instead of having to have an engineer come do it, then they can go do it again themselves. And through that, gained effectiveness and efficiencies. Now, it's always great to hear all the wonderful things that happened and all the possibilities that are out there. But what about the real world? What really happened when we deployed this? Well, we discovered that we have Wi-Fi coverage issues. And in our plans, it's not quiet. We have our retorts and our HSTSs and all the different pieces of our supply chain and manufacturing process aren't traditionally quiet machines. And I think we probably have a lot of other people in the audience who have the same problem. And also, resilience, right? We're a dairy manufacturing operation. So we use fluid milk. Raw milk comes in, and we, pasteurize it, we homogenize it, and then, turn it into powder, turn it into fluid milk, etc. But we're dealing with lots of heat, humidity, water, chemicals, right? What happens if we're cleaning up and somebody left the headset on the floor and it gets sprayed, right? Those kind of things. And then, as with all technology, can people handle this? Is this too much to put on our plant floor users, and are they able to use it effectively, or is it just something that we spend money on and it just sits there? And those are real questions that we had to work through, and we'd have very varied results. And then the user interface, is it easy to use? Is it something that can quickly be picked up, or is it something that just is going to frustrate our frontline workers? Is going to frustrate our engineering teams and end up costing not only capital and time and money, but frustration and lose the desire for additional innovations. And new technology is just challenging. So again, I talked about Wi-Fi. One of the big things we learned: Wi-Fi and sanitary piping are not friends. And one of the things my team has been working on is providing a quick IT response to Wi-Fi coverage issues to ensure effectiveness of headsets. We can have Wi-Fi over the entire plant, but yet in a certain area in the warehouse or on the plant floor, in the manufacturing areas, in our pasteurization process, right? We're going to be sticking our heads with our headset on in weird places that normally you wouldn't put a laptop or you wouldn't put a hand scanner. So all of a sudden we're having to rethink some of our wireless designs to make sure that we're able to truly cover all of the facility and not just 80 to 90%. So working with the plants, making sure that through that IT convergence, that the converged engagement between IT and OT, the different teams, the engineering teams and the traditional IT teams, that we're working together effectively, and the IT's responding. I know that's always something that the OT side is very important to them, is getting quick and effective IT response. And the other interesting piece, which is not that surprising, is the OT engineering's team ability to absorb new technologies. We have between our plants different OT teams who have different levels of engagement with modern technology. And some of our OT teams were absolutely ready for this, and some of them were not. And some of them required additional training and engagement and understanding that this is a new way of doing things and it provides benefits, and really having to, working through our engineering teams and the network team on the IT side, my team, to really champion this with some of the legacy OT teams. And then we have some of our newer automated plants have more, I would call, tech savvy OT engineers, and they are just consuming this at a rapid pace. They are thinking new use cases and exciting new opportunities that we can leverage beyond even just for video conferencing, but for even data analytics and additional pieces, which we'll talk about in a minute. So, and they're evangelizing technology to other facilities. So we're getting, it's not IT saying, hey, use this, hey, use this. This is now the manufacturing and OT community coming to IT saying, hey, we need more of this. Hey, we need more of this. And a lot of it is thanks to the people using the technology. Our tech savvy OT engineering teams are excited about it, engaged about it, and they want it everywhere. So some of it is so they can support the other facilities that they're responsible for more easily. And it just makes their life easier. And that's an exciting thing to see new technology come in that is not wasteful, but it leverages new opportunities and new capabilities for our teams. So what's next, right? We brought it in, we got it, we've met our crawl and walk goals, but what are our run goals? We'd love to, and we're working through some initial prototyping phases of leveraging the augmented reality view to provide additional context to our equipment operators, right? Safety warnings, we look at a machine through the AR system and we're able to see that, this is a high temp or this is an ammonia pipe, be able to call out those alerts. Being able to pull out OT vitals that we're able to instead of just having physical HMI screens, you can actually be able to monitor multiple machines no matter where you are in the facility. So you can have a single operator running 2 or 3 or 4 machines instead of just a single operator running 1 or 2. And then an augmented reality view of data points and additionally documentation, training, et cetera. So the capabilities are relatively limitless. It's all about development. And then again, engagement with the business and the operational technology teams to work through what they'd like to see come next. And then the next piece is we'd like to get a headset at every plant in the enterprise. And that's a very simple line with a lot of implications. It includes wireless refreshes and ensuring that we have firewalls that, between all the different OT and IT networks. And it really, but by providing that, we'll be able to, again, allow the other departments, our audit, QA, IT, research and development, to be able to virtually travel to any plant in the country and do audits, see what equipment's going on, talk about periodic maintenance and predictive maintenance and walk through those different pieces. So it's really an exciting time. It's very, again, non-traditional OT convergence, but it's also very welcomed not only by IT as somebody who likes to bring in new technologies, but by the OT side who sees this as a strategic enabler for them going forward. So we're really excited I've been really excited to share my story with you today. I look forward to answering any questions you guys have in the Q&A, and thank you for your time today.
Hello, ladies and gentlemen. My name is Kai Grüning. I'm working for BASF, and I welcome you to my presentation about Ethernet APL and the role of Ethernet APL as enabler for field device digitization. Let's start with a short introduction to Ethernet APL. Ethernet APL is an advanced physical layer to bring Ethernet applications to the field level, even in process industry. As everybody of you know, the process industry have special requirements on the field level. So some of them are, for example, twisted pair cabling for easy technology handling, the need of loop-powered devices to avoid double cabling, long distances, about more than hundreds of meters, and of course, the devices must be deployable in explosion hazardous areas. Looking at the ISO-OSI communication model, Ethernet APL as physical layer is located on the bottom of the model. So it describes the cabling, the plugs, and the physical properties of the communication. And it provides an interface to higher level protocols, like the real Ethernet itself on level 2, the well-known Internet technologies TCP/IP, and more important for process industry, the industrial Ethernet real-time protocols on user level. Now, I want to give you an introduction to the terminology of Ethernet APL. On the slide, you can see a simple topology that makes use of Ethernet APL. On the upper left corner, you see the redundant controller as part of the DCS. And these controllers are connected via a ring Ethernet to its devices. The ring itself is a traditional 4-wire industrial Ethernet, and the ring structure itself provides redundancy for us. One special kind of devices is the APL field switch. It has an own power source and it provides ports where we can connect Ethernet APL field devices. This Ethernet APL field device connection is called a spur. It's intrinsically safe, so it can be used in explosive hazardous areas, and it can transmit power. To deliver the power to the field devices, the APL field switch has its own power supply. Now I show you another topology with Ethernet APL. The connection to the Ethernet ring is now provided by so-called APL power switches. These power switches have a connection to power and are providing the electrical power to the field switches. The connection between the power switch and the field switch is called trunk. In this topology, field switches have no longer their own power supply, but we have the advantage that we can install them in explosive hazardous areas. The spurs that are connecting the field devices with this and the field switches are still intrinsically safe. At the end of the brief introduction to Ethernet APL, I bring up the technical specifications. And I like to focus on a few interesting points because I think they are really interesting for process industry. The first point is the reference cable type. So it's a typical type A cable. So that's the same cable we are currently using for our field bus installations. That allows simple migration of existing field bus installations, and it allows additionally mixed installations between field bus and Ethernet APL. Another very important point is the so-called 2-wires standard. 2-wire intrinsically safe Ethernet allows a simple and easy installation of Ethernet APL in hazardous areas. And last but not least, Ethernet APL is a full Ethernet standard. It's not a special thing just created for process industry where we have to pay special prices for. It's an Ethernet standard we can use of all the other Ethernet standards that are created. Also, we can make use of standards that will be created in future. So this point guarantees us as much as possible that we have here a future-proof technology with a long life cycle. And after pointing out all these advantages and things, I got usually one question from my colleagues. Why do we need 10 Mbit per second for field devices? Before I answer this question, I like to bring up the use case of fleet management for instrumentation. What's behind? The idea is to have a monitoring and evaluation of relevant information of field devices over the entire life cycle. We distinguish between two kinds of information here. Static information, so it means configuration parameters, device identification, and engineering information, and dynamic information, so health diagnostic, additional measurements, and so on. And the idea is now, what would be if we would be able to correlate and reconcile these kind of data with other data sources. So for example, with the process data from the DCS or the engineering data, for example, not only from the DCS, also from planning tools. And of course, with maintenance data. So how often was this field device maintained? What are where are the manuals located, and so on. We have many potential data sources that we can use to combine this information. So for example, PIMS and alarm monitoring or CPM tools. All the planning tools, so CAE, and of course the documentation from our vendors. And last but not least, our ERP systems. To make use of this use case of fleet management, we can set up different business cases. The first one is a plant-wide comparison to show up differences between the as-built status and the plant status. Another business case makes use of the several data sources we have now access to. So think about an overall health status that not only takes into account the status from a field device, it takes also into account the process conditions, for example, because we can access DCS data. Last but not least, predictive maintenance is in range. To realize predictive maintenance, we do not only have the need to use several data sources, we have also the need to create historical data from them and to make use of it. And using this data, we can train a human expert or an artificial intelligence system to predict the future field system or system behavior. This kind of systems is not really new, but from experience, we can state that using these kind of systems is driving our current field bus installations into limits. So why 10 Mbits? That's the one question. We don't know why 10 Mbits, so I cannot tell it to you, but I know for sure if we want to make use of this use case fleet management with all the applications at any time and every application at the same time, then our traditional field bus installations will not be enough and limiting us. To the question, how can we achieve this using APL? If we want to use APL as enabler for IT-OT convergence, then we need an infrastructure to support this task. One idea is here to use the NAMO open architecture. The NAMO open architecture uses the proven in use automation pyramid and adds a backpack to this pyramid. This backpack is an abstraction layer to integrate the fast changing IT world to our very stable OT world. To explain how Ethernet APL and the NAMO open architecture can be combined, we need to have a look at the data flows in the NAMO open architecture. In the gray box, the so-called core process control system is located. So usually this is our DCS together with the field devices. From this gray box, there are data paths that are connected to a plant-specific cloud system. And this cloud system is then again connected to a higher level cloud system. This can be site-wide, company-wide, global, whatever you like. The important part is that all of these data paths are just going out of the DCS, out of the core system. There's only one way back in, and this is secured by a verification of request. And with APL, we can now use this red marked data path here. And the advantage is obvious. So we don't have to build up a connection from every single field device to our plant-specific cloud. And we are bypassing the DCS on our control system. And this means we don't have to bother the control system with things he does not need for his task. And everything we need to do using APL here is to implement the OPC UA gateway. So that translate from the user-specific protocol, so from the Ethernet protocol running on Ethernet APL to OPC UA, so that our data can be read by the IT. Bottom line, APL is a missing link to enable digitization in the field. As physical layer, APL provides the foundation for a powerful Ethernet-based user protocol, and it enables an environment that unleashes the full power of our use cases. For example, fleet management for instrumentation. But it's only a physical layer, so Ethernet APL must be accompanied by a powerful Ethernet-based user protocol to achieve the most important goals that we need in process industry. Simplicity in engineering and maintenance, redundancy mechanisms for high availability. We need an open user protocol to avoid vendor lock-in. We need support of powerful integration technologies. And last but not least, we need OPC UA access to field device parameters. Thank you for your attention. I hope you have many questions in the panel. Thank you.
Hey, thanks for joining. Today's session is titled Data Recording Compliance and So Much More Through Digital Transformation. I am Pete Berry with Sani-Matic. I'm Sani-Matic's Product Management Director, and I'm going to take you through the slides today and have a good time in the short time we have with you. So first off, just want to introduce Sani-Matic a little bit so you have an idea of where we're coming from. Sani-Matic, if I have to give an elevator speech and let someone know what we do, it's automating and improving sanitary cleaning processes. So you can see some of the products that we have there on the screen, as well as the industries we serve. So we serve the biopharm, food, beverage, as well as personal care, nutraceutical type industries. So we are creating cleaning equipment and cleaning components to help those industries clean their process equipment, whether it's a bioreactor on the left, a waste scale bucket measuring some kind of food product, or a beverage filler. We create cabinet washers, CIP systems, things that clean those parts. On the bottom right there is Sani-Matic's new facility that we moved into recently in 2019 in Sun Prairie, Wisconsin. Digital transformation, starting the journey. So where did we start on this transformational journey that we're on and continue to be on? So I threw in that quote. I both love and hate that quote from Henry Ford. You've probably heard it before. So I'll read it out loud here. If I had asked people what they wanted, they would have said faster horses. So I love that quote to really bring innovation, and it's not always what someone's asking for is what you're going to develop or bring to market. So I love it for that reason. I don't like it for the fact that it definitely is. You do need that customer input on it. So right, the customer, the horse buyer in this case, they wanted to move faster. They wanted to transport things faster. So Henry Ford, obviously the automobile did that. It was completely different than what they originally thought. So what we're doing is we're finding a customer need, which is data recording compliance, and we'll talk about that more in a second. But all those industries that we saw in that last slide, they need to clean their process, and various regulatory agencies, they need to record that they cleaned and the various parameters of cleaning. So that was really the need that we started, Sani-Matic started with on this digital transformation journey. But then, the title of this presentation is that there's so much more. We're really trying to expand upon it. So not only fulfill that need in ways that amaze the customer more so than they expected, and find more products and services that we can offer and help make their lives easier ultimately. So what is our product? Sanitron Cloud is the name of the product, and you'll see our graphic, our visual there. So it's an online data acquisition and management system. So as I mentioned in that last slide, our key product here is cleaning cycle report. So our graphic here, I like it. It shows outlines of some of our cleaning systems. So you think the two box rectangle style equipments, those are what's called our cabinet washers. So think of that as like your dishwasher at home, right? So it's cleaning a lot more than the dishes at your home, but process parts for a food industry or personal care industry. So we have fully automated systems. We have PLCs and HMIs, and we have full control of those systems. And there's so much data in there. Existing ways to do that data reporting is chart recorders and manually writing it down, right? Sometimes you build this full automated system, but you're still doing manual logging of your data. So this product connects to the cloud and then translates that into, you can see the graphic on the right there, the cleaning cycle reports. We'll talk about other features like mobile alerts and OEE reports and things like that. So it's translating that cycle data that we get from our process cleaning equipment into knowledge, right? It's transferred into knowledge. But there's also multiple people there, and they're doing multiple functions, and they're communicating, and they have to share that knowledge too. So it's not only the knowledge and gaining that knowledge from the system, but it's also sharing that within individuals at the company, as well as Sani-Matic as an OEM as well. So here's our primary deliverable. Again, it's the cleaning cycle report. So again, relate this to a dishwasher kind of at home. There's various things that are going on during cleaning. There's flows and pressures. There's temperatures. For us, conductivity relates to chemical being added. We use much different chemicals in the food or biofarm type industries for cleaning than you would for dishwasher soap at home. But we're recording those key parameters because we need to know that, yes, this bioreactor or this cooked kettle in a bakery was cleaned. We're also grabbing a bunch of other data too. So user ID, who was logged in, the recipe name, what it cleaned, messages, alarms, comments, approval functions. So all sorts of information we're not only grabbing from our system and then bringing up to the cloud to present to the end user and have them review it, but then they're also able to interact with it, right? They're able to comment on things and send a report over to a coworker and say, what do you think about this? Or have Sani-Matic come in and take a look at it as well. So this was our primary deliverable that we developed with our Sanitron Cloud solution. So again, title of the presentation, and so much more. What else have we really gotten out of this? So we went on this journey to knowing that there's a cleaning cycle report need, that people need to do cleaning cycle reports. We brought it up to the cloud, which is good. It provides some collaboration and other important advantages. But what else, what else can we do then now that that data is here? What else should this product offer? So some of the things you see here are what I call kind of secondary deliverables or product add-ons, right? Kind of the bell that's ringing with the end user or the customer in this case is really, hey, I need clean cycle reports. This product delivers. But then, hey, what else can we provide with this? So dashboard, so you can check all the data live, trending. So I mentioned we're trending temperatures of the wash cycles and the chemicals and things like that in there for data reporting compliance. But can trending be used to also evaluate the system? And when you have trouble, do some troubleshooting and look back at the data and see, at this time and date, 2 weeks ago on the Tuesday, we had some issues. What happened there? Let's take a look at the system. Preventive maintenance trackers. So we're trying to turn, the preventive maintenance more into a predictive or at least a proactive type maintenance, right? So instead of just changing out your pump seals or your gaskets annually, let's take a look at the run hours on the pump. Let's take a look at how many times that valve actually cycles. And when it does fail, that's kind of all right, this is our baseline, and let's look at that and set it so that next time we're going to get a notice ahead of time and say, hey, we're 80% of the way to failing that we failed at last time. Let's change that seal. Let's change that valve. Email, text notifications. Again, because it's on the cloud, this is one that every one of us experiences a lot. For our systems, it's like that dishwasher where you hit start and maybe 20 minutes, maybe 2 hours later, you come back depending on the application and the process. But you're doing other tasks during that time. You're doing some process tasks, or something else is going on, or you're remote. You're working remote that day, and you want to know when your clean cycles are done, so you can talk to someone else about production. So all that collaboration, anything that goes on within our system, we can really trigger those email and text notifications. Trending. So this is, I mentioned earlier, OEE trending. So OEE, or overall equipment effectiveness. So the three variables of availability, performance, and quality. Those are used a lot in processing equipment. So actually producing the product, but we're cleaning the product or the processes that are producing the product. So with that though, our systems are just as well suited to be able to set up and monitor those availability, performance, and quality scores. So we looked at the OEE from a cleaning system side and said, hey, let's define each of these parameters for what it means for a clean system. Define them and then calculate them and show them to an end user, allow them to track them, look at them over time. And the whole point there is not just, it's just not just numbers. What's the goal on this? We want people to be able to set up their system as a baseline. Here's kind of optimal performance. If I see any degradation, here's what I can do to improve it. So I can, again, that knowledge, I can go look and see what's happening. I can figure out some improvements on how to fix that. And then cloud documentation, a really simple one, but I think a really powerful one. So all those instruction manuals and spare parts lists and things that these facilities get, a lot of times that information goes to a certain project manager, someone associated with a project, and maybe that information doesn't get trickled down to a maintenance tech or an operator. So in the same portal that we're doing all this other stuff, we throw some of the key documentation so that again, it's a big knowledge sharing portal so that it makes it more useful for the users. Staying in touch. So this one is kind of, again, preemptively talking about one of our secondary benefits here and kind of the future of this product. So again, our facility there, we're building these systems for food, beverage, pharmaceutical plants. We have a lot of interaction with people up front specifying the system during the design and the build of our system at Sani-Matic there. We engage a lot with the customer. We work with maintenance and quality and the project manager, and they're looking at utilities and all sorts of things. So there's a lot of engagement and staying in touch, obviously, during the system design and fabrication and build. But then the system goes on site. We have field services and startup services that we offer a lot. So we might continue that touch point for the time being until that system is up and operational. But then after that, we leave, our field service team leaves and the system's running, and then we might not know anything about that system for the 5, 10, 15, 20 years it's in operational, unless they go back and reach back out to us. So what do we want to do? We want to stay more in touch with them. We want to see how their system is operating, have a relationship with that customer, really provide them value by, hey, your system is off a little bit, or hey, we're seeing this on your system. So we want to keep that touch point. It's very important from a customer relations standpoint to really, be involved not only during the sale but post sale. We built this system. We're proud of it. We're very proud of our craftsmanship and our automation work and everything we do it here at Sani-Matic, and we want to make sure that's successful for you. We don't want that system to have an issue that could be easily fixed by us that we didn't talk about or didn't know about, really, right? So staying in touch is a huge portion of our Sanitron Cloud platform. And then future deliverables. So I kind of talked into this with the staying in touch, but the secondary deliverables I went through on that last slide a couple of slides ago were more product focused, right? So these were, OE optimization, kind of like a, products related to that cloud service that an end user can use themselves, or the notifications, things like that. So, what's in the future for this? So I use the term services. It's more of a service mentality where because one of these customers has the Sanitron Cloud system, again, we can see all the data that's going on there. So today we get tons of technical support calls. Obviously, hey, I'm having this problem, troubleshooting this thing. How can you help me? There's a lot of phone over the phone discussions on what's going on. Can you check this? Can you look at that? Just simply a customer having this platform and us being able to log in and take a look at what's going on, I'm going to say enhances the remote technical support we can offer. That OEE analysis, so I walked through how you can monitor it and improve, or at least if there's any degradation, bring that back up to the initial operating levels. So a customer might not be comfortable with, hey, my OEE's dropping. I'm not quite sure what's going on here. So can we provide services for system optimization? Can we do this on a on call or a request basis, or can we do that on a quarterly basis or an annual basis? Is that an interest to our customers? I would think so. Customized how-to educational videos. So obviously in these days, there's lots of videos going on, and we try to provide a lot of educational content, not only from a high level in sanitary cleaning process knowledge at Sani-Matic, but also from how do you change this spray bar? How do you make a recipe on my HMI for my cleaning system? How do you change that? How can we be flexible? So we're obviously developing that content, but with this customized portal, we can not only store the documentation particular for their system, but all right, a customer has this type of system and we just created this how-to video. Let's put that there for them so that their operators or their maintenance people that may not be getting other type of videos or kind of aware of Sani-Matic as a company, they can see those easily enough. So more fine-tuned and more tailored content for each and every plant, not only every plant but every system, right? And then augmented reality integration. There's a lot of exciting things going on in that space. Now that system is on site, and our system is tied up to the cloud, and we know all the data, right? We know the flow meter, the flow that's going on. We know the pressure that's going on. We know all the aspects of that data, but from someone looking at it, you can't necessarily see that apparently. So, can we tie into that Sanitron Cloud platform with augmented reality integration to help provide more information for the users and the operators of the system? And then I end with and more there. So obviously these are future looking services, and the best and probably most exciting point of this is that we discover more and more things that we think about every week. We're constantly learning as well. So the next thing that that's going to be added to this list, I have no idea what it is, right? So to wrap up here, digital transformation. So I said IIoT convergence is, I use two words here, and I think I used them throughout the presentation: knowledge and connectivity. And I think it's my image is hiding that last one. I think it's either connection or connectivity. So we're gonna go with knowledge and connectivity. Those two words, right? I started with knowledge, right? Knowledge is the big thing. We have these really smart systems from a isolated standpoint. And we're basically exposing that knowledge to not only the facility for that data recording compliance, but then a lot of other areas we're exposing knowledge that we never even knew we had with OEE analysis and things like that. So it's knowledge, but I think just as important and tied into that is connectivity. So again, that knowledge, going to an operator, if he can then share that with a QA manager, that connection between all those different individuals at the facility across shifts, right? So a lot of times this system might be running across multiple shifts. So I can now share and comment on, my clean cycle report so that the next shift has this knowledge. So there's connection at the plant level. There's obviously a dynamic where there's corporate and individual plant connection that can happen. But then, just as important too, as I touched on a few times, is Sani-Matic's connection to the end user, to what they're doing. So it's not, we have the expert knowledge on our equipment and how it should run and how to optimize it. And without this product, we lose that connection and touch point with that customer. So the connection is just as important, if not the most important, between us and the OEM and then the actual end user. So again, knowledge and connection are my two words. If you remember anything for the digital transformation, the IIoT convergence we're seeing here. So thanks for joining. Really appreciate your time and have a great day.
Hello, I'm Todd Anslinger with Chevron, and today I would like to talk to you about the benefits of modernizing your PCN with the publisher-subscriber model. So as with any new technology, we can't apply technology just for the sake of technology. We need to have a business problem we're trying to solve. So here are some of the business problems we're trying to solve, at least at Chevron. We're trying to reduce the integration time in the PCN. We're also trying to reduce the integration time in our enterprise business systems, trying to extend the life of our low bandwidth Ethernet radio systems, and we're trying to avoid running blind on day one of property swaps or company acquisition properties. And then we're also trying to update our PCNs, our process control networks. So what are the integration challenges? Well, in the Permian Basin, we expect to double our well count, but management said that we're only going to add 30% more manpower. The math doesn't add up, so we have to apply some new technology. So there are 5+ integration points in each facility that we're doing on an upstream location, and you can see those listed there. And of course, since we're doing pull response now, the integration of those points have to be done in series so we can rule out any human error along the whole process. So speaking to those points of integration, what you have here is the process now is, of course, we're not going to change running a conduit and pulling wire from a wired sensor to the PLC. That won't change. But we have to have integration point at the PLC. You have to do integration point at the local touchscreen. Then you've got your control room graphics you have to update. And then in our case, we do some flat file movement from the HMI to the DMZ to the level 4. And also we get our historical data pushed over into Pi at level 3, push that into our decision support center HMI graphics, and then push that also to level 4 to make it available for the people at the business level. And of course, since these are all pull responses, you have to verify that those points make it there, right, at each point. So that's the process now. Now, what could the process be with publisher subscriber? With a PLC or an edge device that is spark plug compliant, you should be able to make the change at the PLC level or edge device level, and it automatically publishes to your broker when your control room HMI and Pi server, who can understand the birth certificate that comes from Sparkplug, when it sees that birth certificate, it could automatically create the graphics at your control room, automatically create the entry into Pi AF structure. You could pass that through to the next broker. Your Pi and your decision support center, or at least that's what Chevron uses, could automatically create the dashboard graphics there for your decision support center. And then even going up to your business level, other production databases, your business systems that could understand that birth certificate could automatically create these things, and it doesn't take any manual intervention. And quite honestly, in the the time period of iPhones, isn't that how you expect it should work nowadays? So go on to the next one. So that should have addressed the reducing integration time in the PCN and the business systems. Now I want to move to my next point from the beginning is how can publisher subscriber help in a low bandwidth Ethernet radio system? So first of all, publisher subscriber by nature only sends updates when a value changes. So imagine if you have these, I'll call them fat objects that you develop at the PLC level and that are at the HMI, if you have 100 parameters wrapped around a single process variable, which you could do with PID parameters, different alarm set points, alarm digitals, that type of thing, it could be easy to do. But when you're doing poll response system, you're pulling all of those values up. Now, granted, you may put them in different poll groups, but the thing that's going to be changing is that process variable, let's say that tank level. So when you only send that process variable because it's the only thing changes, we did some testing and we calculated that conservatively, we only use 15% of the bandwidth of that radio. So that's one thing as far as bandwidth. The other thing is store and forward is built into the software. So with some of these older radios and you get noise floors in the region that you're, running close to your noise floor, sometimes our radio systems drop out. Well, how it was now is that if you drop out that signal, when you bring up a trend, you just have a gap in that trend. It goes down to 0 and you don't get that back. So we could combat that by putting in, a $5,000 or $10,000 card in each PLC and set that up to be the store and forward. But now with new technology, that's already built in to the software from the software side of it. So that handled the low bandwidth radio. So now what research or what observations did we make when we did our research on the different systems that we have? So basically we just took lean sigma measurements. And to explain those, I like talking to pictures. So let's go here to the pictures. So for the first system we did was a multi-vendor setup. So vendor number one's PLC local touchscreen, going to vendor number two's control room HMI graphics, and then to our historian. Setup number 2 was all the same vendor vertical from PLC to historian. Setup number 3 was what I'll call version 1 of a publisher subscriber system a couple years ago. So what we did is we took and added a tank object and propagated that through existing systems. So with the competitor PLC and HMI system, it took 22 minutes to replicate that to the system. And this is with experienced people who do this often. It wasn't newbies doing this. The second system, the single vertical vendor system, took roughly half the time, which you would expect. You should get some efficiencies by having a single tag name database throughout the whole system. And then with the last one, the publisher subscriber system, it took 4.5 minutes. So about 20% of the top option there too. So basically this was firing up the PLC software, adding an object, tying the hardwired level transmitter into the object and saving it, downloaded it, and turning off the PLC software. And because from that point, it replicated all throughout the system, all the graphics, all the databases, and actually all the way up to a mobility piece, which is really not apples to apples because the other two options did not have that mobility piece. Why is it important that we have a standard MQTT specification? Well, MQTT is open, which is good. So anyone create their own version, which is good. But that's also the bad side. It's open and anyone can create their own version. So we're focusing on Sparkplug for the first reason is that it has session awareness. So it has what I was talking about before, the birth certificate. If you want to control via this link, you have to be confident that you're connected to that PLC or to that DCS. So you need to know that you're session aware that you have connection to that PLC. And this is because if you have stale data, let's say, you could see that tank level be at 10 foot on a 20-foot tank level. And if you don't know that that connection is lost or that that data is stale, you may look at that number for days. And when actually water is spilling out of the tank because you lost connection to that data. So it's very important to have that session awareness for that environmental reason or for that catching that process upset. The other thing that the session awareness does, or the birth certificate does, is if you think about that, working that up into your business systems and your analytics, if your analytics sees a birth certificate for a new pump number one, let's call it, and it says, okay, I've got analytics that we apply to pump number one. So I'm going to automatically apply them to that pump, automatic put it in the dashboard so it just shows up. So that's part of that understanding that birth certificate and working its way all the way through the system to automatically create dashboard graphics for you. Now the next one is around, it accounts for hierarchy of our facilities, and this is at the tag name level. So if you imagine a tag name that you would want to see, like in Chevron's case, it's going to be chevron.upstream.Permian Basin.Midland facility number one .pump 101. Okay, you would want to see that all at the tag name level so you can search on that. Well, in a typical MQTT tag, you have to build that hierarchy in the JSON script level. And we don't want our automation engineers to be JSON coders. So that gives us an example there of an advantage. And the other thing is that this specification has been given to the Eclipse Foundation so we can manage this open standard. And that's really advantageous to you because if you think about it from the vendor side of it, if Chevron creates its own MQTT specification and we ask one of our vendors to build that into their hardware or their devices, they're not going to be really keen to do that because that only gives them a market share of like this for Chevron. Whereas if they can see that this is an open standard and that a wide range of people are using it, even not in oil and gas, they'll be much more likely to create that functionality or that capability in their devices. And you can see that right now because there are vendors that have Sparkplug compliant PLCs and cards and devices right now. And then the other thing around that is that standard from a common specification, it would be easy, let's say if all oil and gas producers use this as a common standard, if we did property swaps with someone in the Permian Basin, or if we acquired a company, if everyone had this standard, we could just spin up a new broker, let's say in the cloud. We don't even need to do infrastructure like SCADA radio towers, and we could repoint that to that new broker or to the different broker, and we'd have our data coming in like that. We wouldn't have to wait to put our Chevron Bless control system on a facility to get that into our SCADA system. So I want to summarize now why using Sparkplug to modernize our PCN is advantageous. So the first thing is, obviously, we showed that the publisher subscriber could significantly cuts our integration time, down to 20%. PubSub also only uses 15% of your Ethernet radio bandwidth compared to a poll response system, which gives you advantages. You can apply new technologies through that Ethernet, that extra bandwidth that you have. And also, if you're going to operate by this, you need to have session awareness in order to running blind so you don't take the risk of a possible environment event or process upsets. And then implementing Sparkplug in the current Purdue model is a step towards operating in the cloud that you can easily facilitate that change in the future. So we're looking at baby steps here. If we get PubSub in the PCN and a tower falls down, you want to point that straight to the cloud and do cloud SCADA. Again, it's just repointing it to a different broker and you've got that data coming in. And then around the Sparkplug specification, I'm going to influence you to join the Sparkplug working group. And the reason being is if there's an open specification that you can guide to put in there what you need to satisfy your company, you have that, you can do that in the Sparkplug working group instead of creating your own specification and trying to manage that. That would be quite a nightmare. And then feel free to contact me at tnslinger@chevron.com if you want more information on that. Thank you very much, and I look forward to questions later.
Well, thanks, Todd, and I want to thank all the speakers. It was a great job, and so much great content that we're down to our last 10 minutes. So all we're really going to have time for is we have 5 panelists. That gives each panelist 2 minutes each to answer. I'm going to ask one single question that I'd like all the panelists to answer, and it's really, how is your company, please, providing ITOT, helping your customers accelerate on their ITOT convergence journey? Just a simple question, a 2-minute answer. I'll start off with Wes. If is Wes Sylvester available, if you could just answer that quick question from Cisco. And if Wes is still looking for the new mute button, I'll see if Andreas is available to answer that question.
Hi, Craig. Yeah, this is Andreas. Pepperl+Fuchs is involved mostly in process industries, but also in discrete. We have 2 business units, and in either side of these units are extremely involved in ITOT conversions, because Pepperl+Fuchs provides the infrastructure that makes it happen. As we've just heard from Kai's presentation, is Ethernet APL is going to revolutionize the way we are looking at field instrumentation. So Pepperl+Fuchs with their infrastructure is helping to break down these types of barriers. Anything that goes on with an industrial protocol is supported by infrastructure or instrumentation provided by Pepperl+Fuchs. And this knowledge is always paired with the systems knowledge, and particularly with the knowledge of application in hazardous area, one of the strongholds that we have always been in. And we're actually quite proud about the fact that single pair Ethernet, as APL is based on, is now structured in such a way that process industries can even participate in it, because we helped in the IEEE committee standards work. We helped them understand what the needs of process industries are, so that all of our audiences here can benefit from it. Otherwise, we would not be getting a chip or a PHY or an infrastructure that can be utilized inside and outside process industries for cost reasons.
Okay, thank you so much, Andreas. How about John Vincente?
Sure. Thanks, Craig. So first of all, obviously, just from the presentations today, you can see that there's a variety of ways that companies are going after this convergence, right? And whether it's communication technologies, cloud, analytics, AR, VR. So, I mean, this topic is very, very wide. I think what we're doing from Stratus perspective is addressing that transition of what that computing infrastructure, that merged computing infrastructure looks like, bringing technologies like virtualization, advanced virtualization technologies, so you can address concepts like device sprawl, workload consolidation. But Stratus is known for actually world-renowned for its high availability and fault tolerance technologies. And frankly, we stand alone in modernizing software and hardware capabilities. We think that one of the biggest challenges for the suppliers and end users, as you move towards this converged, fused direction you've talked about, is how do you manage high availability or avoid downtime in the manufacturing environment and support remote operations. And that's one of the biggest areas for us is addressing the complexity of this convergence with high availability and fault tolerance. I think that's probably our major value add to this convergence discussion.
No, that's great. As Wes, how about you?
Yeah, hey, I would actually echo the comments around dealing with high availability. One of the things that we've been trying to do with many of our partners and in deployments is simply figure out what is and what isn't priority, and where can we use technology to help manage that priority. So, for example, real-time video like the Dairy Farmers America team did, if they're working on a PLC and wanting to have real-time feed to an expert in a remote location, can we tag and prioritize that over the technician who might be using an iPad to enter performance data, historical performance data at the same time, for example. And so we're always trying to figure out how we really prioritize. And I know that when we worked with that team of dairy farmers and some of our other folks that we've been working with, a lot of it is around prioritizing not only the data and the technology, but also the projects themselves. So that's a critical piece.
Okay. How about Eric?
Well, good afternoon, and thanks for having me here. So Rockwell's approach to this is to look at it from a holistic approach, and that is tying in not only the downstream equipment suppliers for the OEMs like Sani-Matic, but then also tying that together with the data available from the end users and across the entire spectrum. So partnering technology like ThingWorx together with companies like PTC and Microsoft Azure, Rockwell has a definite advantage to being able to tie in the entire loop of data from beginning to end.
Okay, and Travis?
Hi, Craig. Thanks for having me here as well. So our company, Inductive Automation, we provide an industrial application platform. So, software platform to build HMI and SCADA solutions. Really, we're fundamentally rooted on the OT side of the fence, and we're really trying to solve those operational challenges that people have there, and to leverage open standards, to leverage modern technology, and get access to more data and make that data more accessible, and really bridge the gap between OT and IT. And today, if you look at in the pandemic with what's going on, it's really important to stay connected and to be able to get data and to do more with that data. And fundamentally, we're trying to provide those tools to allow customers to do that easily and securely by leveraging all of that. And open standards is one thing that we really are it's quite important. So we can bridge the world between proprietary and get that open. And as Todd was talking about, MQTT is as a great example of leveraging the Sparkplug specification to have this open standard for ways of getting access to more data and making it more accessible somewhere else is really incredibly important. And really we're behind that 100%, and can't wait to see when we could just plug any device in and it'd be plug and play, and ultimately we could discover all the amazing information that's there with its context, and do more with that, right? Start looking at analytics, machine learning, bridge to the cloud, and a lot more. So if we can make that technology accessible, easy, then customers can start that transition to digital transformation a lot more effectively.
Okay, that's great. And now if we could have a quick 30-second response, it's the Monday morning quarterback question, which means if you could do anything different based on what you've learned, how would you do it differently today? And this one I'm going to ask, it's the same question for the entire panel, like 30 seconds. Maybe I'll start with the speakers this time. How about you, Peter? Monday morning quarterback, 30 seconds.
Yeah, I think I just saw a question come in on kind of the merging of IIoT from a culture standpoint. So I think just getting every aspect of the business on board is probably the best thing, and we should do that as early as possible. Monday morning quarterbacking earlier than we did. But for an OEM like Sani-Matic, we're building equipments and skids, and this whole software thing is it's new. It's new for the development, but it's new for selling, right? It's new for every aspect of the business. So I'll just leave it at that. It's just kind of getting your whole organization on board with it.
Okay, how about you, Todd?
Well, if I forget what we've done for the last 30 years in the process control network, I would say today I would want our standard facilities to just be like plug and play. You plug it in, you turn it on, the data comes back and it automatically populates our dashboards and has a common look and feel for all the operators and engineers to use.
Okay, great. How about you, Kai?
I would make sure that we can exchange data between the systems, right? That's for the use case of fleet management. This is really a challenge today, and because there is no standard currently available, and yes, so we can use it. We could use it today if we would make sure, or would we have to make sure if we have to make sure that we can exchange data.
Okay, and finally, Patrick.
Actually, I want to kind of, what Peter said and the question that we saw organizationally. I think, at the end of the day, it's a business and IIoT, right? There all comes back to business and business stakeholders, business buying is critical to any piece of this. And especially when you're starting to talk about some of these, with the fusion, you start talking about a shared service across the enterprise. And I think sometimes, it's easier to start in a certain vertical within the business or certain business unit and make sure it works. But, if you could come back and take out all the politics and everything else, being able to peanut butter that across as an enterprise service, I think would be a huge capability. Again, if, Monday morning quarterback started all over again, but, sometimes it's just not feasible.
Yep. Hey, thank you very, very much. I, again, apologize for rushing the Q&A, but I think it was really important to get all the great content from our fabulous panel of speakers. And but thank you, panelists, for participating. We have some great workshops coming up in 15 minutes, so we look forward to you all tuning into that. And then another round of sessions today at 3 p.m. Eastern time as well. Again, this is Craig Resnick, ARC Advisory Group. Thank you so much, and I look forward to seeing you later at future sessions.